We are now at question 5 of this CXC CSEC January 2014 General Paper 2 exam video solution. And in this question 5 part 1, we are asked to construct a triangle ABC using a pair of compasses, a ruler, and a pencil. And the triangle ABC should be such that the length of BC will be 10 centimeters, AB will be 6 centimeters, and AC will be 8 centimeters. So let's go through the steps. So firstly, I'm going to draw a line segment 10 centimeters long to represent the line BC. And this is it. Now this is drawn by using our ruler and measuring 10 centimeters on our ruler and drawing that line. So we can mark the ends of this line BC, and so we have our line BC 10 centimeters long. Now the point A is going to be somewhere in this region. And as we are told, the distance from B should be 6 centimeters. And so what we can do is open our compass to 6 centimeters. That is, use a ruler and open our compass to 6 centimeters. And then with the point of a compass at B, we will make an arc that is 6 centimeters in radius. So let's go ahead and show that arc. And that is it. This arc is 6 centimeters from the point B, and therefore the point A is somewhere on this arc. Now the distance of A from C is 8 centimeters, and so what we will do now is open the compass to 8 centimeters. So we will use a ruler and measure 8 centimeters with the compass, and then with the point at C we will make an arc to cross this first arc, and this is it. So that's our arc. This arc is now 8 centimeters from the point C, and so the point A is at the intersection of these two arcs. This point here is where A would be located. This point A is now located such that it is 6 centimeters from B and also 8 centimeters from C, and so this is the location of the point A. And since we now have the position of the point A, we can complete the triangle by joining A to B and A to C. So let's do that now. So that's it. That's the line segment AB, and that line segment is 6 centimeters long, and we can complete the triangle by joining A to C with that line, and it is such that the length of AC is 8 centimeters, and that's our triangle ABC. Now part 2 wants us to measure and state the angle ABC, that's this angle right here. So what we can do, we can bring our protractor in, and the protractor must be positioned carefully such that the baseline is on this line that we're measuring from, and the center of the protractor must be placed carefully at the vertex of the angle that we're measuring. And we want to measure the angle up here, and we must measure the angle from 0 upwards. The protractor has two scales, one from 0 upwards and the other from 180 degrees downwards. We have to ensure that we measure the angle from 0 upwards. And if we now observe this angle that we want between these two red lines, measuring from 0 upwards, up to here is 50 degrees. So that's our 50 degree line right here. And so our line is at 50, 51, 52, 53. And so this line AB is 53 degrees to this line BC, and we can show that that's the angle that we want. That's the angle ABC, and the protractor is showing us that that angle is approximately 53 degrees. So let's put that on the diagram and move the protractor out the way. And so that's it. Our angle ABC is 53 degrees, and that's the answer for part 2 of question 5A. Let's move down now to part 3. Now part 3 wants us to complete the construction of a quadrilateral CABD, and this quadrilateral must be drawn such that BD is equal to BA and CD is equal to CA. But it is important to observe the orientation of our quadrilateral, and our orientation must match the letters as shown here. CABD must have the same orientation with respect to the diagram. And so if we look at the diagram, CABD has to be down here because the orientation C to A to B is anti-clockwise, and so D must be such that the anti-clockwise orientation is maintained, and so D must be somewhere down here, and therefore our distance BD must be equal to our distance BA, which is 6 centimeters, and so D down here must be 6 centimeters from B, and also our distance CD must be equal to CA, and so the distance CD down here must be 8 centimeters, and so we can construct to find the point D by drawing an arc that is 6 centimeters from this point B, and also drawing another arc that is 8 centimeters from this point C. So let's go ahead and show that. We will open our compass to 6 centimeters, and with the point of a compass at B, we will make this arc. This arc is 6 centimeters from B. And then we will complete this construction by opening a compass to 8 centimeters and measure that with a ruler, and then make an arc from C that is 8 centimeters in radius. And this is it. So this arc now is 8 centimeters from C, and therefore this is the point D, and we can show that. And that is it. This point D now is 6 centimeters from B as given by this arc, and also 8 centimeters from C as given by this arc. And we can now complete this quadrilateral by joining the points B and D, and that is 6 centimeters, and also joining the points C and D, and that line segment is 8 centimeters, and that's it. We have completed our quadrilateral. And now, just to identify this quadrilateral before we move to the next part, we will observe that this quadrilateral ABDC has two pairs of equal adjacent sides. This side and this side, they are adjacent and they are equal in length, and this side and this side are also adjacent and equal in length. And when we have a quadrilateral with equal adjacent sides, that quadrilateral is called a kite, and we can show that quadrilateral ABDC is called a kite. Let's move down now to part B of question 5. Now question 5 gives us a metallic block in the shape of a prism. This is a diagram of a metal block in the shape of a prism, and we are told that this prism has a trapezium as its cross section. This trapezium PQRS is the cross section of this metal block, and the trapezium has PS and QR as the parallel sides, and PQ represents the perpendicular distance between those parallel sides on the trapezium. And then we will observe that the height of the metallic prism is 3 centimeters. And so what we have is an object with a uniform cross section. And let's go to the questions. Now, the first part wants us to calculate the area of the trapezium, that is the end area of this object with uniform cross section. And the area of a trapezium is equal to half the sum of the parallel sides multiplied by the perpendicular distance between the parallel sides. And so the area of the trapezium is given by this: half the sum of the parallel sides. The parallel sides are 12 centimeters and 6 centimeters multiplied by the perpendicular distance between the parallel sides, and this is the perpendicular between the two parallel sides. And so this formula gives the area of the trapezium. When we do that calculation, the result is 135 centimeters squared. So 135 centimeters squared is the cross-sectional area of this metal block. Let's move down to part 2. Part 2 wants us now to calculate the volume of the metal block. Now, the volume of an object with uniform cross-section is equal to the cross-sectional area multiplied by the length. And in this case, this is the uniform cross-section, which we know the area is 135 centimeters squared. And the length of this object now would be this height here, 3 centimeters. And so the volume is given by the area of PQRS, that's the trapezium end, multiplied by this height, ST. And we can show that calculation. The volume of the metal block is 135 multiplied by 3. And when we do that calculation, the result is 405 centimeters cubed. So that's the volume of this prism, the metal block. Let's move down now to part 3. Now in part 3, we are told that the mass of the metal block is 1.5 kilograms. That's the mass of this metal block. And that 1.5 kilograms is equal to 1,500 grams. And I've done this because we'll be required to give our answer in grams. So the 1.5 kilograms is the mass of the metal block, and that 1.5 kilograms is actually 1,500 grams. And we are now asked to state what the mass of 1 cm cube of the metal in this block would be, and we have to give our answer in grams. That is, what would be the mass of 1 cm cube of the metal that is used in the block? Given that the mass of the metal block is 1,500 grams, we are now required to state what the mass of 1 cm cube of the metal in this block would be. Now we know that the block is 405 cm cube, and therefore the 405 cm cube is equivalent to 1,500 grams. This is the volume of the block, and this is the mass of the block. And so if we want to know what 1 cm cube of the metal in this block would be, all we need to do is divide this relationship by 405, and that will give us the mass that is equivalent to 1 cm cube of the metal. And let's show that. And so 1 cm cube of the metal would be equal to 1,500 divided by 405 grams, and that result is 3.70 grams. And so the mass of 1 cm cube of the metal that is used in this block would be 3.70 grams. And that's the answer for that part of this question. And that's the end of question 5, and we'll do question 6 in the next video. See you then.